let me get ready and let's start. I'm gonna set up my timer as well. Hello, everybody. Welcome to What is Kubernetes? My name is Juanpi, and I'll be your presenter. Let's start. Oh, wait, I don't know why this has skipped like 10 sessions. 10 slides in one go. This is much better. Quick introduction first. My real name is Juan Pablo, but nobody calls me Juan Pablo. Everybody calls me Juanpi. Juanpi NR is my nickname in Drupal.org and social networks. So that's the easiest way for you to find me if you want to reach out. I live in Cercedilla, which is a small village by the mountains of Spain, of Madrid, sorry. It's like 1 hour away from downtown. And work-wise, I'm a senior developer at Lullabot. I've been working at Lullabot for more than 8 years. Lullabot is a strategy, design, and development company. It's employee-owned and it's distributed, so there's no physical office. Regarding Kubernetes, I got into this via continuous integration and reading DevOps. I've been through a phase where I've read as many books on DevOps that I could find, and it's funny because many of the strategies that were explained on these books, Kubernetes gives them by default. We'll see some examples later in the session. By reading, studying, writing articles about it at the Lullabot blog and just tinkering with different cloud providers, it's how I got into the Linux Foundation trainings, and that's how I got these 2 certifications. One is about managing clusters, and the other one is about how to run applications in a Kubernetes cluster. Let's start with a general question, which is, what is Kubernetes? The best definition that I found was from the official website. I'm going to read that loud, and then I'll make a couple points about it. It says, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. It's true, it's portable because it supports a lot of cloud providers, and you can even use it on your own cloud. You just need to extend from an interface written in Golang, which is the controller interface, and there you are. You can start using your own cloud under your own rules. It's extensible because Kubernetes cluster is defined by a set of objects. These objects are YAML files. We'll see some examples later. And you can create your own that extends from the official ones to suit your needs. It's open source. The repository, it's in GitHub, and it's one of the most active projects in GitHub right now. I think that it was a few weeks ago that the repository reached 1 million pull requests. So you can imagine what's the amount of activity that happens in that repository. And then another question that I made myself, and I researched a little bit for answers, is, what's Kubernetes to Docker? What I found out by looking at different blog posts and documentation sites about this is that the question is nonsensical because they're different things and they can even work together. The best definition that I found is from the Microsoft cloud documentation. It's called Azure, and it says Kubernetes is meant to run across a cluster while Docker runs on a single node. This made sense to me because if you have used Docker, chances are that you have run a single container locally because maybe your project needs a RabbitMQ or a Redis service to read from. You may have used Lando or DDEV, which spin up a bunch of containers so you can have a local development environment. Docker is great for this. Docker is also great to do things on continuous integration, like, for example, spinning up an environment so you can run tests, for example, or run a live preview. However, if you want to run containers in a distributed environment, Kubernetes is I think, a better fit for this because it takes care of all the network that happens, managing all your applications, making the best use possible of the cluster. If we go a little bit back in time, I realized by looking at the docs that Kubernetes is just the result of the evolution of how to manage infrastructure. If you want to run a website, you can just pick a server, run it in your house, or rent a virtual machine on a cloud provider. That would be the example on the left. You know what? Let me use the pointer. I discovered this recently. Yes. So here you're managing everything by yourself, and your applications are running up on top of this infrastructure. If you're using virtualization, which got famous some time ago, you are having full machines on top of another machine, and each of these machines are not sharing the operating system. While when containers started appearing, they use a much more relaxed approach because they do share the operating system. And Kubernetes would sit here between the container runtime and the operating system. And this would run on a cloud. So there would be several nodes in a cluster. And Kubernetes will take care of running each of the pods. We'll see more about this in a bit. In your cluster, trying to make the best use of your resources to run your applications. Here is a very simple cluster. Let's suppose this is a cluster I created in, for example, Google Cloud or AWS. In this example, there is a Kubernetes master on the left side. This is a master node. It's also known as the control plane node. And then on the right side, there are 3 worker nodes. They are also known as minions. The Kubernetes master or control plane node, it's composed of a set of services and daemons. There is the kube controller manager, which is a daemon that just runs a set of loops to check for the status of the cluster. The cloud controller manager offers us an abstraction layer so we can interact with different clouds. The Kube API server is the brains and interact with each of the different services, and it also communicates with the nodes via REST API. etcd, it's a distributed database system. It's a key value store that holds the status of the cluster. It's very robust, and it allows you to have, for example, multiple master nodes. etcd has a protocol in which it will discover the other etcd databases in the other master nodes. They would synchronize with each other, and they would elect a leader. So this protocol supports multiple failures, yet still it will work. Although it's not invincible. I've heard that there are cases where you need to restore it. There is a backing up system that should take into account, but still, very, very robust system, and it's meant to be used on this kind of distributed environments. And finally, the kube scheduler, it's a service that, given a specification, like, for example, I want to deploy a new version of my Drupal application, it will check for the status of your worker nodes and decide how to deploy that new version of your application in the worker nodes. As for the worker nodes, we have 3 here. Each of them, they have a kubelet and a kube proxy. These 2 services run on each of the worker nodes. The kubelet takes care of managing the pods running on a worker node. I have a definition here at the top, which is that the smallest operational unit you would use on Kubernetes is the pod. And a pod represents a set of running containers. For example, a pod can be the MySQL database service, or Nginx plus my Drupal application code. A pod can have 1 or many containers. Usually they are Docker, but they are not necessarily need to be Docker. There is also the kube proxy, which takes care of all the network communications with other nodes, with other pods in other nodes, and even outside world, and also communicates with the kube API server. By the way, I didn't mention this. I'm leaving some time for at the end for questions, so I'll read the chat. Here are the basics of the life cycle of a cluster. You would start by just creating the cluster on a cloud provider, creating the master node, installing kubeadmin there, then adding more worker nodes to it. Then once you have the cluster running, imagine that this kube is my Drupal project that I have containerized. I would deploy this on my cluster and it will start running. I would expose it via either an ingress controller or a service. These are two Kubernetes objects. We'll see some about Kubernetes objects in a bit. If I need my application to be able to manage a higher amount of traffic, for example, I can scale it up within my cluster, and Kubernetes would take care of all the network communications for me. And then later, when I have, for example, created a new release for my application, I can tell Kubernetes to deploy it, and it will do it in the following way. This is a pod containing my application. It will deploy to each of the worker nodes where is it running a new version of the pod. Once it verifies that this pod is running, it will then perform all the network changes, so traffic will go to the new pod while the old one will simply be destroyed. I mentioned objects a few times already. Here is one, this one on the right. This is how you define the architecture of your cluster in Kubernetes. It's a YAML file. In this case, this represents a deployment. Let's go to the left, which is an identical way of creating a deployment. There is the imperative mode, which is via commands, and there is the declarative mode, which is defining a file and then running kubectl apply and then the file or the set of files. So here what I'm doing is I am creating a deployment of my application, which is called Nginx deployment. I am deploying simply the Nginx web server. This is a Docker image, but this could be a custom image that I've created with Docker that contains not only Nginx, but also my application code, my Drupal application. I'm saying that I want this to be replicated twice in my cluster, and I'm exposing port 80 so I can browse this on a web browser. This command is the same as creating this file and running this command. There's no better approach here. Besides, usually you would use both because writing this kind of files is very tedious. Usually you would just copy and paste them from the official documentation. It's really handy as well to run this command on the left with a dry run option and outputting the resulting YAML onto a file. So then you can perform some edits. Usually you would have this set of files under version control. So you would commit them. And then finally, in an ideal world, there would be some continuous integration job that would notice your changes and deploy that to your cluster. I've recorded a quick demo. This is the simplest example I could find to run Drupal locally. What I'm doing in this example is I'm going to use Helm, which is a package manager for Kubernetes. It's very useful because when you're running an application with Kubernetes, you would end up with a lot of different Kubernetes objects, these YAML files that we've just seen. And Helm is able to package them on a single tar file and also allows you to have placeholders on these YAML files, and this could go along with a configuration file that will fill those placeholders. The placeholders could be things like, for example, the MySQL username and password, things like that. So let's click on play here and quickly see it together. Okay, first, wait, because, okay, there's some issue sometimes with the quality of this video, but hopefully it's good enough. First, I'm going to just view my cluster. I already installed here Micro Kubernetes, which is a Kubernetes distribution that is lightweight. I only have a single node that acts both as a control plane and a worker. and there is nothing. I have no pods running here, no applications. So next I'm going to Artifact Hub, where I can find Helm charts. A chart is a collection of Kubernetes objects. And I'm locating here the command to add this repository that contains the Drupal chart that I'm looking for. So this will register this repository on my local registry. And then I'm going to run Helm install, the name of my application, and then Bitnami Drupal. This will do a lot of things in the background. It will gather those chart, that chart, the set of Drupal, the Kubernetes objects, and perform the deployment on my cluster. I'm inspecting here the pods in my cluster. There are two, one for Drupal, one for MariaDB. They are running. They are actually starting. The next thing I'm doing here is I'm going to check the logs of the Drupal pod. We can see that it's trying to connect to the database server. The other pod is still bootstrapping. So this will take a couple seconds if I don't remember well. And then it will continue with the installation. There you are. MySQL, well, MariaDB in this case is ready. So we see the output here saying that it's running the Drupal installation. There are more things that were created on my cluster among these two pods. That's why I'm opening a new terminal where I'm going to inspect the objects that I have installed. That's how kubectl is the command line interface, by the way, to interact with my cluster. So there's these two pods that I mentioned before. There is a service to expose Drupal on port 80 and port 443. There's another service for MariaDB on 3306. And then there is the deployment object, a replica set, and a stateful set. These are different Kubernetes objects that take care of different aspects of my application. Coming back to the logs of the Drupal pod, it's done. We can see here some health checks looking for user login, which are getting 200. That means that my application is running and I can browse it. So what I'm going to do now is I'm going to obtain the IP address of the service that is exposing the Drupal pod. That's the IP address, and I'm going to open a new browser tab. There you go. Drupal running locally. Ta-da! What happened in the background? A lot of things, actually. First, we run Helm repo at Bitnami. That's the repository, the Helm repository that contains the Drupal chart that I wanted to install. By the way, this is just a generic chart that contains bare bones Drupal, install Drupal, but obviously you can create your own Helm charts to package all the Kubernetes objects in your application and use that with Helm. But in this example, I've used this one from Bitnami. When I run Helm install, this replaces variables in the set of charts, like I mentioned, the MySQL database, for example, and then runs kubectl apply the set of objects in a single YAML file. What we have underneath is my local cluster. As I said, I'm using micro Kubernetes, lightweight Kubernetes distribution. It's great for tinkering locally with Kubernetes. I have a single node on my cluster that acts both as a control plane, as a worker node. So the control plane receives the command with the specification and creates a few things. A MariaDB pod, along with a volume that contains the database files, a Drupal plus Nginx pod that also contains a volume for the public file system. You may have heard about volumes in Docker, and they are not the same in Kubernetes. The biggest difference that I found between them is that volumes are more, they have a closer relationship with a container in Docker, while in Kubernetes, a volume can be used by more than one container. And that's what allows you to scale up your application. We'll see some examples of this specifically for the database. And finally, there's another pod here, which is the service. Not a pod, another Kubernetes object that is the service that exposes Drupal on port 80. That's why I can access the Drupal application on a browser. a few tips on if you're going to run Kubernetes in production. I have experimented with these 3 cloud providers, AWS, DigitalOcean, and Google Cloud. It's surprising that I didn't have to make changes on my Kubernetes objects to run my application there. The setup is slightly different, but more or less the setup it's very similar. Besides, I wrote a series at the Lullabot blog where you can find the differences. There are examples there. There's a repository. There is some CI as well. So there is a link on that series at the end of this session. While on the right side, these are common tools that you would use if you are running your own cluster. For example, FluentD is used for logging. Helm, we've seen it, is a package manager for Kubernetes objects. Linkerd, it allows you to set up a service mesh. I got this on my list of courses, but I haven't got into this yet, so I cannot say anything about it, just that it's popular. Prometheus is for telemetry, so you can monitor your cluster. Rancher gives you a web interface and you can view and manage your cluster. And Vitess is a project that allows horizontal scaling for databases. There is a great article by the Slack folks where they are using Vitess to do horizontal scaling on their databases, and it's very, very interesting. If you want to go with a partner, these two have, we invited them to the Lullabot show and tell, DDev and Amazy.io. You wouldn't interact directly with Kubernetes if you decide to host your application in their platforms. They offer you an abstraction layer that allows you to make the most out of Kubernetes, but hiding the complexity. So good folks to talk to if you're planning to go this route. Finally, how to start. I'm going to post here some links on how can you go further on the Kubernetes journey. Obviously, the documentation, there's a section in the documentation that has graphs that, I don't know for you, but to me, they were really, really interesting because I could get a picture in my head on how each of the main concepts of Kubernetes work. Obviously, the official repository, it's very interesting as well to check it out. In a few days, there is KubeCon and Cloud Native Con, all about Kubernetes and other cloud projects is there. So I highly encourage you to look at this project. It's managed by the Cloud Native Computing Foundation, which I posted the link here. There is also a Slack community that is very interesting as well. It's a good way to learn. And then finally, there is the link that I mentioned about the article series on continuous deployment and managing infrastructure as code. I used, as I said, Google Cloud, AWS, and DigitalOcean to run a very simple Drupal site, and then I added some CI on top of that. So that's the end of the session. Thank you very much. I hope you liked it. Please evaluate it. There's a link at the top of the comments and at the bottom of this presentation. I'm going to go now through some Q&A. I saw that there was a lot of activity, so I'll try to find the questions. And also, shout out because we are looking for project managers, front-end developers, and back-end developers. There's a link here, and there is also a link to these slides on my Twitter account. Feel free to reach out to me if you have any questions. So let's go to some of the questions. I see that says Q&A. Okay, I'll read them out loud. Michael Stenta, how might a Kubernetes-based deployment work with or not Drupal's multi-site functionality? Example, hosting multiple separate sites that use the same install profile, but unique files and config. Okay, let me think quickly about this one. I see. Okay. This is out of my knowledge of Kubernetes. Each of the, assuming that you're using a different domain for each of the multi-sites, there is a Kubernetes object called the ingress controller that will do the routing for you by handling each of the different domains and directing it to Drupal. If you have a single domain, it doesn't really make a difference. Only it's just that you would direct the traffic to the Drupal application, and I think that Drupal would do the rest. So I cannot think of many more things that may go differently by using a multisite, because it's a thing that Drupal manages. All the files would go on volumes for sure, and these volumes, there are volumes that work on the cloud, and they can be shared by different nodes in your cluster, so that there wouldn't be any problem with that. So in general, I don't think that you would face many challenges. It would be just about setting up your multisite correctly. That's it. Hope I answered your question, Michael. I have another one from Josh Miller. Why is Kubernetes so polarizing? Is it because the cure is worse than the disease, or is it because it's simply really hard to understand? I'm not really sure, Josh. I understand what you mean by polarizing, like whether it's hard or good or bad, or hard or easy. I don't know. I can say that I am not a sysadmin. I'm a web developer, and Kubernetes really got me very, very interested. It's hard, at least for me. It's hard. I had to learn a lot of things, and I'm still learning a lot of things. But it's fun as well. Previous infrastructure patterns they seemed more boring to me, or at least not as appealing as so I could study them and try them. So there must be something about this. But anyway, that's all I can say about this one. Paul Whitner, how are files thinking of file uploads etc. Synchronized across containers? I mentioned this in one of the slides. Imagine that you have several pods running your application, and this would be synced via the files would be synced via volumes. There are volumes. There is a type of volume in Kubernetes that is shared among your cloud, among your cluster. So that's it. The only challenge I can think about would be collisions. If two pods try to write on the same file, I'm not sure if that would trigger an error or not. I guess so. That would be a fail upload. But in theory, this would be transparent to you. You would just set up the the connection with the volume, and then even when you are deploying new releases of your application, the pod that is connected to the volume would be disconnected, and then the new version of your application would be connected to it seamlessly. So you don't have to worry about any of that. I'm seeing if there are any other questions. Yes. Nishan Pillaratne. Sorry about pronouncing your last name. You mentioned Kubernetes was hard. Can you describe what topics you found challenging to learn? I remember that when I was doing the certification, I found it tricky to play with network policies. Network policies are a set of Kubernetes objects where they tell you, for example, in the exam, we want that the pods that are tagged as Drupal application can communicate with pods that are tagged database on this port and only on this direction, while the database can only receive the communication from those pods and these other things. Testing that teaches you a lot of how Kubernetes handles network communications. You need to do a little bit of networking in order to verify that one pod can communicate to the other one. You need to jump into the pod and then perform network requests to make sure that it can do it, and then go to the MySQL and verify that it can communicate as well. That was tricky. that was tricky to learn. As for, I'm thinking about any others. No, that was the hardest. The thing is that documentation is very, very clear. And when I was preparing for these exams, I found really, really, really good sites that have both tasks and their solutions. And I would do the task and then look at the solution and see if it was the same. And that teach me a lot of the Kubernetes internals. We have, oh, actually, I think it's the top of the hour. Scott, am I right? So we don't have more time for.
It's 12:05, so you have like an extra minute or two.
Okay, I'll take it then. Let's see. I have another question. Sean the Armand. At what point is it necessary to consider horizontal database scaling in Kubernetes? I think that pretty early if you have a considerate amount of traffic, because initially you would just run one pod containing your MySQL application. That pod is connected to a volume that has the varlib MySQL files. If you want to scale that up, I can only think of using Vitess that adds a layer of abstraction for you to be able to scale that horizontally. I haven't tried Vitess myself, so Sean, I recommend you just search in Google Slack Vitess, and you'll find the article, and they get into details on why they had to do this and how they were doing it before. So you can find all the details, because I haven't played with this myself. Next question, Josh Miller. Is there a good example of a website that would benefit from Kubernetes and a good example of a website that would not? Is this a multi-purpose hammer or a single-purpose tool? From my experience, stateless applications, meaning applications that don't need a database or a storage system, are by far the easiest to manage by a Kubernetes, and where Kubernetes does its best, because you just configure the cluster, and if, for example, you get a spike on traffic, Kubernetes will take care of everything. You define your pods to handle a certain amount of CPU requests, memory, and when the control plane node sees that your pods are getting too busy, it will spin up new pods and do all the network communications to communicate them with the external world. So those cases are great. However, thanks to tools like Vitess, now you can scale stateful applications seamlessly as well, via, in this case, for the database. So you can also run Kubernetes for stateful applications like a Drupal application. That would be my two examples. And no, it's not a single purpose tool. There are still cases where just you don't need Kubernetes. You just need to set up a different hosting approach. I guess it depends on how much you want to allow spikes in traffic and how much control do you want to have on the infrastructure, because the good thing about this is that it gives you a lot of control of defining the infrastructure with code that goes tied to continuous integration and other concepts that are really good. I think I got to finish here. In a few minutes there is the Dries note. Hope you enjoy it. Thank you so much. Feel free to reach out if you have any other questions, and please review this session. Thanks and bye.